Hello, I'm Dr. Adam Baker from Rocket Engineering Limited and Cranfield University. I'm going to talk about launch, which is one of the highest profile parts of the space industry and the one with the most obvious sustainability consequences, mainly because of the propulsion required. Launch in the UK has never happened before, but making that work is going to be critical to allow our space industry to grow and continue to compete with all the other big players like the USA, China, and Russia in the 21st century. It's also important to keep in mind that because of increasing launch capacity around the globe, and UK spaceports plus our rockets are going to add to that, satellites are increasing rapidly in numbers above our heads. This is starting to have grave sustainability consequences, but how we address that growing space debris challenge while requiring propulsion and rockets, that's a topic for another video. I want to start with the fact that all space missions begin with a need. The need creates the mission. For any mission, we should be able to write a mission statement that tells us three things. The objective, the mission objective. So why are we doing the mission? The mission users, who the mission is for. The mission operations concept, how all the mission elements work together. 1, 2, and 3, the objective, the users, and the operation concepts. These lead to something called the space mission architecture, a collection of spacecraft, orbits, launch vehicles, operation network systems, and sometimes other things that make a space mission possible. And this ultimately leads to data or information being produced and then applications. This is the kind of the why we do space, really. Remember, though, that space missions have sustainability consequences. Launch is one of the most tangible and significant ones. Therefore, we need a clear rationale for why to do space missions and why we need launch. But let's boil it down to the launch challenge, at least to us engineers. So, this is Professor Martin Sweeting, who founded Surrey Satellite Technology Limited and who I used to work for. And he's standing there in his clean room with a satellite. He's got a satellite. Doesn't it look great? Does some really clever stuff. It cost quite a lot of money, but it's no use to anyone sitting on Earth. So the question is, how can we transport it safely and sustainably into Earth orbit? And particularly, from the point of view of this video, what are the issues for the launch vehicle engineer? Now, in order to understand that, you need to have a few basics under your belt. Orbits, trajectories. Okay, so here's a little cartoon of the Earth with the equator marked on in a dotted line. Orbital trajectories or orbits. An orbit is a closed, invisible pathway in space which satellites follow. Under Newton's first law, if a vehicle goes sufficiently fast, its trajectory or its path gets pulled into a circle or an ellipse by the Earth's gravity, and it never returns to Earth. That closes the pathway. There's a nice little video on the Sun Space University Network YouTube channel that shows in a bit more detail how orbits are defined. There'll be a link on the end of this slide that you can follow or just search for it. And rockets that go into orbit to deliver things like space stations and capsules and satellites ultimately end up in orbits. There are different types of orbits as well, different orientations relative to the equator. More on that in a minute. There are also trajectories. So a trajectory might go from the surface of the Earth up into space and then back down again to the same point or another point. Missiles were the earliest form of rockets, and they follow these open paths, often called suborbital trajectories. It's kind of an arc and it's open, and certain types of space vehicles follow those. Virgin Galactic's Spaceship Two. So if you're still confused, don't worry, okay? There's the YouTube video, and I'll show a quick video clip explaining the real basics of orbits. This is a model of the Earth. And you can imagine an orbit as a kind of big imaginary racetrack going around it. So I borrowed my children's hula hoop to show what this racetrack might look like if you can imagine an orbit in space positioned around the Earth. It's invisible, of course. Spacecraft, like this, will follow the racetrack around the orbit. Rockets are designed to get spacecraft from the surface of the Earth up and into or onto the on-ramp of the orbit, okay, or the racetrack. Okay, the on-ramp of the racetrack, spacecraft going into orbit. So orbits can have different sizes and shapes and orientations in fact about 5 different parameters, usually defined relative to the Earth's equator, like this. And in fact, you can find out more about orbits, see them described in a bit more detail, in a Sun video linked in another slide. Recalling from another video, to get into space, you need to travel at about 8 kilometers a second, or 8,000 meters a second. So the first question, if you're interested in launch from the UK, is where could you launch your rocket to accelerate at that kind of velocity? As you can imagine, this isn't something you can do from just anywhere. Launching safely, when you start thinking about it, dictates a number of things. Rockets need to be launched over unpopulated areas, and ocean tends to be best for that. So the Earth rotates to the east, and if you can launch due east from the equator, the added kick of the delta V benefit is the greatest. Sadly, the UK is not on the equator, and in fact, rocket flight from most countries, and the UK is really no exception, are constrained by geography, populations in towns, cities, and the countryside, and people on the move, such as in ships and airplanes. We'll see why in a minute. So in the UK, we've been thinking about how we might launch our own rockets into space for quite some time. In fact, the current launch or commercial spaceflight program got started just over 10 years ago. So to ensure that our rockets can reach orbits in space safely and efficiently, we need to avoid flying over our own citizens, neighboring countries and their populations, sea traffic, oil rigs and aircraft, and in particular, active airspace. That's why we're developing multiple vertical launch sites in Scotland, suitable because most launch activities, that's the best place in the UK, and also some horizontal sites as well. You can see the vertical sites here. And if you don't believe me about the air traffic, take a look at this video from NATS, the UK's National Air Traffic Service. Here's the air traffic over the North Atlantic for a short period in a typical day. Rockets, effectively large hypersonic missiles, will need this air traffic to be rerouted around their trajectory. Assuming the flight of the rocket can be arranged safely, what happens next? Activities at a launch site involve many things, but one of the most hazardous is launch site functions, loading tens or hundreds of tons of high-energy, combustible, and potentially explosive rocket propellant into the vehicle. This also has to be done quickly and the rocket ready for launch, as the majority of propellants, in order to be made dense enough to make the rocket efficient, need to be super cold or cryogenic. You can see that here. So as a result, sitting there in the often warm spaceport sunshine, well, not usually in Scotland, will make them return to the gaseous state, which you can again see in the picture, creating a potential overpressure hazard and a risk of an explosion. Even when relief valves are included to allow propellant to vent, the steady loss of cryogenic liquids will eventually lead to a launch scrub. That's a common term for a postponement, meaning propellants have to be removed from the vehicle to make it safe enough to work on while waiting for the next launch window. It's expensive and can mean a longer wait while nearby traffic clears the area. In the UK, our rockets, while a bit smaller than some more well-known vehicles, pose exactly the same hazards. The propellants can, in the event of an accident before or during launch, combust or explode. These can result in a number of effects, things like blast, flying fragments, fireballs, toxic gas clouds, extremely hazardous to persons or wildlife. A failed launch even has the potential to impact persons or property in the vicinity of the launch site, from the control room to visitors and viewers. So designing a launch site to address the potential risks of fire, blast, or explosion means generally you need to separate propellants, propellant loading, fully fueled rockets, and rockets about to or in the process of launch from people who are running the launch campaign. Different levels of safety, shown in this table on the left, correspond to different distances and locations, shown in this map on the right. And that's what the designer of a launch site has to put together. All of this careful thinking and design enables safe operation of a spaceport or launch site, regardless of what's going on in any given launch campaign. This is the UK's first licensed vertical launch site on the remote Shetland Isle of Unst, almost as far north as you can go. While still being part of the British Isles, the Saxavord launch site here, or spaceport, is the most remote place in the country and is well placed to launch rockets, given their hazards, away from the population who might be put at risk by an accident. It also benefits from the most direct trajectories to many orbits our spacecraft might want to operate in. But there's still sea traffic, air traffic, and weather, which we haven't talked about, to consider when planning safe launch operations. And those are all good reasons why having more than one spaceport is a really smart idea. Here's a couple of videos showing why an accident, which can happen when dealing with rockets, can be extremely dangerous and put spaceports and launch complexes within them out of action.
We actually ignited 8 motors. Unfortunately, one of these motors has developed an anomaly. We know now from the debris analysis that we have conducted in the last days that this anomaly was a very unusual one. It was most likely a fire in the oxygen pump. That's really difficult to contain. This damage has spread onto neighboring engines, and when the stage introduced the emergency stop procedure, it appears that everything that followed thereafter was simply not sized for this extensive damage from this oxygen fire in the turbo pump.
There are over 200 nations in the world, and nearly all of them are building spacecraft and increasingly making use of space-based services and opportunities. Last time UK launch services checked, there were 19 active launch sites, but only 10 nations capable of launching objects into orbit. Growth has been most rapid in the United States, which now launches more objects into space every year than all the other nations on Earth combined. 2024 saw 98 launches from Cape Canaveral in the eastern US and 47 from Vandenberg in the west, rapidly thanks to SpaceX becoming the world's biggest and most active launch sites. But given the importance of space to the world, many more nations are developing rocket launch vehicles and investigating feasibility of their own launch sites or spaceports. Here's a short interview with Vicky, who's CEO of UK Launch Services, to tell you more. Hello, I'm here with Vicky Montag, who's the CEO of UK Launch Services Limited, and we've got a rocket behind us. Yeah. So Vicky, CEO of a launch services company, that's pretty cool.
Yeah,
Pretty awesome.
not gonna lie, it's pretty cool.
Oh, what does the company, what do you do?
What do we do? So UK Launch Services is an engineering consultancy. We're based in London, and we predominantly specialise in spaceflight, particularly launch, hence launch services. So what that actually means is if you're an organisation, whether that's a government organisation, agency or a commercial organisation who's looking to launch and you've never done it before, we support that.
That help people along the process.
Yes, yeah, exactly. So we don't build rockets, we don't tell them how to build rockets, but we do things like, if you're going to build a launch site, you're going to want it in this place, you're going to want to separate things by these distances so it's safe, so it's operational, so it's commercially successful.
Okay. So let's say country X, wherever it might be, says we want to do launch. We build satellites, we don't do rockets, we need to be able to deliver our satellites in space. And they ask you for help. What do you think is the first thing that you would need to talk to them about, the first consideration in that process?
So there's a couple of things for them to consider. The first bit is a bit boring. It's regulations. It's like, do you have the legal framework to be able to actually do rocket launch? And not many countries do because they don't do it already. So we can support the country through that, development of regulations. But also it's things about geography. Where are you? Obviously you can't launch to every inclination from everywhere in the world. You can't do it from populated areas. If you're on I always have to do this every on the west coast, that's less than ideal because you tend to want to launch east or north or south.
Okay, you're saying some places are probably better than others. Some places it might be completely impossible to launch from because there's too much stuff around you or there's no ocean or whatever.
100%. So I'm just trying to think of, Spain, for example, probably not the best place to launch. Not terrible, but there's much better places.
East of Spain, which is generally the direction you might want to launch in. There's lots of stuff.
There's people, there's ships, things like that.
And
it's probably not the best example. Portugal.
Okay. What about the UK then? I mean, is there a reason that the UK might be a good place to launch?
Yeah. So first of all, we have a great satellite industry here. So we've already got a market. You're not putting up rockets for no reason. There's usually something on them.
They've got customers.
So you've got that potential. We are quite far north, so that does limit the orbits that are accessible from.
Right. And if you go east, I guess you fly over our friends in Europe who might be considerably less friendly if we fly rockets over their heads.
Yes. So you kind of wanting to be heading north-ish, so you can do polar as long as it's
right. And those are good orbits for our small satellites.
Yes, they're perfect. Okay. So that's actually quite a nice coincidence. We've got the satellites, we've got the orbits, we've got potential to get into the orbits those satellites to get into.
Any particular challenge? I mean, that all sounds great, but launch is difficult, as we know. Not everyone can do it. So, any particular challenges for launching from the UK? Assuming we've got regulations, which we have, and assuming we've got a direction to go, and assuming we've got satellites, what's difficult about it?
So it's usually those flight paths. So the launch sites tend to be in Scotland, though we do have in Cornwall, but that's a different matter. That's great because they're go north. You're not flying over other bits of the UK.
Okay, so the trajectories look good.
Yeah, but it's really busy airspace. You've got lots of transatlantic flights that kind of go.
North Atlantic skies.
Yeah,
true.
Really,
Heathrow's quiet today.
Yes, I know. I didn't get woken up this morning by the first flight of the day.
Yeah.
It's also quite busy marine traffic there as well.
Of course.
So obviously you've got things that you don't want to hit and things that you don't want to drop things on.
Yeah.
There's also, you've got Faroe Islands, you've got Iceland there as well.
Oil rigs too. We've got oil rigs there. There are really high value assets as well. I see.
So there's a lot of marine life. And,
so the detail is it's quite challenging to arrange launch so it happens in a safe way.
Yeah.
Okay. Well, somehow we've contrived to have 7 spaceports on our kind of book of spaceports.
Yep.
And we're going to see, well, we've had one failed launch so far from a spaceport. That was unfortunate. It seems to be a bit quiet down in Cornwall. But something's definitely coming up at Saxonville. But what about all the other ones? I mean, really? Are we going to have 7 operating spaceports in the future? What do you think?
Realistically, probably not. There is an argument to have 1 or 2 or 3.
Okay.
It would be nice if they all work together. So that actually
complementary,
so you have that resilience. So Saxonville, obviously, in terms of location, geography, there's not many people there, there's some sheep.
Mm-hmm.
That's a good location, but it also has its challenges. It is, the weather's, yeah. So being able to back that up with a second launch site would be, it would be good for the country.
Okay, and that's all vertical launch at Saxon as well,
Yeah.
and there are some arguments, I guess, to say air launch might be a useful thing to have too, so maybe Cornwall could be a good complement.
Yes, and of course Cornwall's already got the infrastructure there, they've already got the license and so on, so they just need tenants.
I'm thinking about it, I mean, you don't just have to do launch at the spaceport, clearly that's the main reason for being. I think there are other activities you could do at spaceports, like say Mojave over in America.
Yeah, so you can do basically technology development, anything that's actually hazardous, so they are sort of very, very, launch sites are basically very, very specialised explosive ranges, they're like missile test sites.
Testing, that's what we're talking about?
Exactly.
Right.
So,
propulsion testing, for example.
100%, yeah.
Yeah, okay. So there's lots of things these other spaceports that might not support launches long term could potentially be doing to still justify the spaceport.
Oh, absolutely, support the infrastructure. At the moment we have a couple of companies in the country, more in Europe as well, so they can provide that space for people to come and do, again, very, very hazardous operations safely, because that's by nature set up that way.
And that's good business for UK launch services, because you can support all those different hazardous activities with things like safety cases.
Exactly. Yeah.
Cool.
That's what we do.
That's what they do. Hey, thanks. Great.
Thank you.
Okay, so let's assume that you can address all the safety challenges. In order to obtain a launch license, you also need to demonstrate to the regulator, which in the UK's case is the Civil Aviation Authority, or CAA, that you're going to have no significant environmental impact around the launch site, within the area that your rocket will fly in, and to the world as a whole, where we're increasingly conscious of sustainability and environmental impact. So here are some headline numbers for a typical large rocket. This is Europe's Ariane 5, launched almost 120 times over its nearly 25-year working life. And you can see on the left that most of the vehicle mass, which is about the same as a fully loaded large airliner, is rocket propellant. And this all gets burned on the way to orbital velocity. Only 10% on the right, but still nearly 100 tons of vehicle is made up of physical components, structures, electronics, engine nozzles, etc. And here's the kicker. Every single one of these 117 launches, with all of those different parts from the right, ended up one way or the other in the ocean, because, with only one exception at present, all rockets are thrown away after each flight, very different to an airliner and very unsustainable. So here's some more headline numbers as to what the impacts of an Ariane 5 launch really were. So first of all, a single Ariane 5 launch, a particular type of rocket, there are several different types of it, produced around about 18,000 tons of CO2. Okay, that's nearly 18 million kilograms of CO2. It also produced nearly 90 tons of ozone-depleting chemicals, hydrochloric acid in this case, from the solid rocket boosters that were absolutely essential to lift the vehicle off the ground and accelerate in the early stages of its flight. It also produced nearly 1,500 tons of heavy metals from the tanks, the engines, the pumps, and the other high-performance parts, which all ended up in the sea. And there were a number of very measurable toxicity effects of the production and launch on important environments that we care about. And finally, per launch, close to 22 gigawatt hours of energy are consumed to build the rockets, transport the rockets, operate the rockets, and launch the rockets. That's more or less what 6,000 houses use in a year. That's per launch. Astonishing, really. And this was done for a study that I took part in for the European Space Agency several years ago. Let's have another look at a different case study. that was a rocket. What about a launch site or a spaceport? So I worked a few years ago on a spaceport design called Space Hub Sutherland, at one point planned for use by Orbex, a UK-based rocket company. So this was supported through an organization called Highland and Islands Enterprise, HIE. And they were responsible, amongst other things, for making sure an environmental impact assessment was carried out. This is a requirement for any major planning development in the UK, spaceport or otherwise, and to make sure that the site could actually be built. And it's also an important part of obtaining a license to operate the site under the UK space industry regulations. So while the site construction impact was found to be perhaps broadly comparable to an Ariane 5 launch, this was over the 15-month construction period. It's still almost 17,000 tons of CO2. And over the actual operating period, where somewhere between 6 and perhaps 12 launches per year were suggested, the yearly emissions from the company Orbex that hoped to use the site and the spaceport itself was estimated to be around 1,000 tons. Now, these figures don't include the emissions associated with actually building the rockets. That's being estimated separately by Orbex. Now, although these figures seem large, it is fair to say that they're extremely small in the context of total emissions of both Scotland and the British Isles. But let's look at a third case study about sustainability of launch. Everyone's favorite big rocket, I guess, or at least in the space industry. Starship, if we believe SpaceX's projections on how much this will lower the cost of launch, is the one that's going to allow us to go and colonize the Mars, visit all the other planets, do extraordinary things, and set up a spacefaring civilization. Great. So the first thing to say is that this is the world's first fully reusable rocket, very different from Ariane, very different from Orbex. And you can see it in the middle picture landing after a test flight. So based on what I told you earlier, SpaceX intends to reuse each vehicle many, many times rather than disposing of it each launch. And that's really important for reducing the impact of launch. Yay! Okay, but let's look at it a bit more closely, those headline numbers. So each Starship weighs around 5,000 tons fully fueled at launch. Now, about 500 tons of that is vehicles and things that aren't going to be burnt but might be used up during the flight. So roughly 4,500 tons of oxygen and methane propellants are going to be combusted to carbon dioxide and water. Both of those are really potent greenhouse gases, and that's going to happen every time it launches. And they're going to be emptied into the atmosphere, and a good portion right into the stratosphere. There's also some more rocket propellants are going to be burnt to allow the Starship to turn around, slow down, and land for reuse. Now, okay, that's a lot. SpaceX is targeting daily launches of this. If you add up those numbers, actually they come to about 0.01% of global annual greenhouse gas emissions. And okay, that's a really small fraction, but it's all still adding up. And those greenhouse gases are going straight into the stratosphere, which is where they really, really have an impact. Seems kind of worrying to me, and I think it's definitely worth looking into in the future. So environmental impacts of launch then. Well, launch numbers are going up. Okay, you can see from this graph produced by a colleague of mine in the space industry, Richard Lowe, who's the CTO, Chief Technical Officer for the Satellite Applications Catapult, that launch numbers are really starting to increase, particularly over in the US. So they launch, to be fair, almost everyone else's payloads, but they've been going up a lot in the last few years. And I guess this is a natural evolution of wanting to carry on using space to benefit all our lives and being able to explore the universe and do all the other fun things. So launch rates are inevitably going to go up. The thing to bear in mind is that launch has a far greater impact per unit of goods delivered than any other form of transport, simply because rockets are going faster, there's more energy involved, and at least so far, but that is changing, they're being disposed of each time because it's very difficult to reuse rockets. To date, that really hasn't mattered that much. the relatively low cadence of launch compared to any other form of transport, so a total of about 300 flights in 2024, has not been significant. But as launch rates continue to increase, and that's a pretty significant hockey stick curve there on the right, I think it's going to become more and more significant. So we have to keep an eye on this. And one of the ways to do this is to think about how we can do launch better. So to do it more sustainably, given some of the impacts I pointed out, okay, a standard is one possible way to do it. Standards, these encourage the design, manufacture, operation, and disposal of anything really, but launch vehicles in this case, to be undertaken in a more sustainable fashion. And the UK is really good at doing standards. We have our British Standards Institute, and we're a kind of a founding member and a key participant in the International Standards Organization. And that's one of the things that's being developed at the moment in the UK. Key thing for this, key part of this is considering reusability, okay? Only recently demonstrated for space launch, but it's absolutely central to this standard, is that really going forward, all launch vehicles should be reusable. And the second thing is that launch really isn't just about the vehicle. It's about all of the operations and the rest of the space mission in totality. The whole supply chain from end to end needs to be considered in order to consider sustainability properly. So one last thing then, I think it wouldn't be complete without mention of an alternative way to launch rockets. So I worked on this earlier in my career, and it's been tried a couple of times, most recently with Virgin Orbit. So air launch is a way that an aircraft carries a small rocket to the launch point and releases it with some forward velocity and above most of the atmosphere. Offers a number of possible benefits, not least of which is you can have a very efficient and increasingly green these days aircraft acting as the first fully reusable stage of the launch system. Now, unfortunately, as you might be aware from the sad story of Virgin Orbit, air launch has kind of had mixed successes, really. Not necessarily due to the technology, however, the economics of mixing an aircraft and a rocket and making it safe on the ground and offering a growth path towards the inevitable demands for a larger rocket that come from all satellite launch customers means that it's been very hard to make air launch commercially successful over the long term. It is great from a safety point of view, particularly in the UK where it's busy. I think there's a really good opportunity here to do air launch right. It's only been done a couple of times in the past. Neither of those have been successful long term. I think it's a great opportunity to do this right in the UK. We've got some really excellent knowledge of aircraft and rockets and rocket propulsion. It's a really good location in the UK to develop, test, and ultimately operate an air launch satellite delivery system. So watch this space. So to recap then, the how, the safety, and the sustainability of launch in the 21st century. We've covered what rocket launches are, the why, the how, what direction they need to go in, which is obviously crucial, plus what safe launch means for the UK, given our geography, population, maritime and airspace activities. We've also looked at the safety implications of launch operations and what goes on at a spaceport not far from you and what's needed to keep staff and visitors and property safe. And then finally, taking a good hard look at the sustainability implications of space launch in the 21st century, giving you some perhaps sobering figures, but I think where the UK is concerned, there's cause for optimism. There's opportunity and there's challenges for the UK to really do launch differently through developing some standards and some best practice and perhaps taking a look at air launch, which is perhaps a really good fit for how our country's configured and the small satellites that we build. I'm Dr. Adam Baker, Rocket Engineering and Cranfield University. Thanks for watching.